So we can open up PDB files. So you enter in the PDB accession number, and then you will quickly be loaded around and in your protein. Sometimes it's going to be way too large. You can see here I'm going to make it small enough so that you can visualize, but we're going to now pull ourselves inside this molecule. I already talked to you about the enzyme active site. So we're going to walk inside this protein and we're going to review that enzyme active site again. So here you can see right here, I can see the structure of the NAD cofactor that's there. So there's the niacin component, and down here now we can see here is our 4-carbon malate substrate. So all the stuff that we talked about when I went through this just kind of on a flat surface, we can see here's the histidine residue. It's going to deprotonate that hydroxyl group of malate. Here's again the carboxylic acids are in proper position because of 3 arginines. There's 1 arginine, here's the other arginine, and then a 3rd arginine residue. Okay, so those are 4 of the 5 important amino acids that we have here. So again, that OH group is going to get deprotonated by this histidine. This histidine is made into a better base because of an adjacent aspartic acid residue that helps to increase its basicity. So again, this aspartic acid is going to increase the basicity of this histidine. That histidine's nitrogen is going to deprotonate the OH group that we have on our malate substrate. Then we've got a carbon atom with its hydrogen as a hydride that's going to be abstracted by our B vitamin here. Here's the nicotinamide, the niacin portion of our NAD. That's where we're going to transfer that hydride. Again, that's the rest of that B vitamin cofactor. Amino acids can't do that chemistry. So that's the chemistry that's going to happen here, and we'll walk ourselves back out of the enzyme active site. If you keep your eye on it, you can see how tiny that enzyme active site is within the context of the entire protein. A little bit easier to look at now that you can see the entirety of this protein here. Again, malate dehydrogenase is a dimeric protein, so here's the 2 monomers that we have. Here's the dimer interface. Some of our mutants that we're looking at are mutated in that dimer interface. So nice thing here is when you have this list up, you can just literally scroll through and highlight and see those different residues, okay, those different portions of our protein. So just a last look here, walking around our room where we are inside a 3-dimensional space with malate dehydrogenase.